When most people hear the word dam, they picture massive concrete walls holding back immense hydraulic power, built and managed by federal engineering bodies. But this is also a dam. Across the country, hundreds of thousands of engineered structures seamlessly masquerade as natural scenic ponds. The United States Army Corps of Engineers maintains the National Inventory of Dams. It tracks roughly 90,000 structures, but inclusion relies on strict size and hazard thresholds. When you account for smaller earthen embankments and low-head structures excluded from that database, researchers estimate the true number of dams in the U.S. exceeds several hundred thousand. Over decades, vegetation grows over earthen walls, softening their geometry until the man-made impoundment becomes indistinguishable from the surrounding woods. Because these structures evade both national databases and basic visual observation, they form a massive, unquantified blind spot in American infrastructure management. During the 18th and 19th centuries, engineers built countless unmapped structures to generate hydraulic head for grist mills, textile mills, and ironworks. As the industrial utility of those mills vanished, the dams themselves were left behind. Over generations, the mill ponds transitioned into scenic community lakes or recreational areas. The legal danger arises as these large historical parcels are subdivided for modern residential real estate. These forgotten industrial assets are frequently subsumed into private ownership. A homeowner completes a property purchase, believing they have acquired a natural water feature. Often, it is only after closing that they are notified they now own regulated water infrastructure. Acquiring one of these unmapped structures triggers an immediate, unpriced transfer of legal liability, of maintenance costs, and of hazard risk directly to the unsuspecting property owner. The modern engineering challenge is figuring out how to locate and catalog this infrastructure across millions of acres of varied terrain. This is where geospatial tools come in. Using digital elevation models and LiDAR, engineers digitally strip away surface vegetation to reveal the unnatural topography beneath. In this elevation data, engineers look for specific anomalies, rigid linear features, sharp elevation drops, or unusually straight embankments that interrupt the organic flow of natural stream valleys. To process these vast topographic maps at scale, researchers are increasingly deploying artificial intelligence and computer vision algorithms to flag potential unmapped dams. These algorithms are specifically utilized to hunt for low-head dams, small structures that rarely appear in state registries but pose immense public safety risks. This image captures a low-head dam. These structures are highly dangerous because of their physics. The continuous flow over the drop generates powerful, recirculating underwater currents, creating visually deceptive drowning machines. Geospatial technology acts as the essential first filter, turning vast watersheds into a targeted grid of potential regulatory liabilities that require on-the-ground verification. Let's examine a specific field verification case study: the pond at the Institute for Advanced Study in Princeton, New Jersey. Looking at this photograph from ground level, the pond perfectly camouflages itself as a timeless, naturally occurring feature of the local ecosystem. To bypass this illusion, engineers use a temporal screening method. They pull historical data to establish a timeline of construction, eliminating the possibility of natural formation. This is Albert Einstein, who worked at the Institute from 1933 to 1955. During his tenure, he frequently walked the surrounding open landscape. Aerial photographs from the 1930s confirm that no water body existed in this location during Einstein's time. Compare that to imagery from the 1980s, which clearly shows the pond fully formed as a deliberate part of the campus development. Proving a structure's mid-20th century origin permanently strips away its natural disguise, legally classifying it as an engineered impoundment. Once temporal and geospatial data flag a site, an engineer must conduct a physical morphological screen to identify the legal components of a dam. This image demonstrates the first critical indicator, the crest. You spot the gently rounded top berm separating the upstream water from the slope. This geometry proves you're looking at an earthen wall explicitly engineered to hold back hydraulic pressure. The second critical indicator is the presence of designed outlet or spillway structures. In this photo of the IAS pond's outlet, you clearly see man-made materials, specifically a stone-lined overflow structure cutting into the grassy bank. This provides evidence of controlled discharge, proving a deliberate intent to impound and manage water levels. The third indicator lies downstream. Engineers examine the area below the embankment for telltale signs of controlled flow or leakage, such as isolated wet areas, seepage, or scour. By recognizing these three morphological indicators, crest, spillway, and downstream flow, anyone can look past the appearance of a scenic pond and identify a regulated impoundment. Discovering these morphological indicators on private residential land carries direct legal and financial consequences. This diagram illustrates the cascade of regulatory responsibilities. It begins with discovery, leading immediately to hazard classification and mandatory engineering inspections. Then comes the physical maintenance burden. Owners must actively manage vegetation to prevent roots from decaying the earthen embankment. The external liabilities of neglect are severe. The failure of even a small dam leads to localized flooding, destructive downstream erosion, and damage to connecting infrastructure. A private dam is not a static landscape feature. It is a decaying machine requiring continuous, expensive intervention to prevent catastrophic failure. Because of these costs, how this liability transfers during real estate transactions is a major issue, but transparency varies wildly depending on state jurisdiction. Virginia utilizes a strict buyer beware approach, where the seller makes no representations. Connecticut, on the other hand, requires sellers to disclose only officially registered dams. Proposed legislation in New Jersey seeks to mandate explicit disclosure of a dam's existence, its hazard classification, and its inspection history prior to sale. But these disclosure laws are only effective if the homeowner or the property inspector possesses the spatial literacy to know what legally qualifies as a dam in the first place. As America's mid-century infrastructure ages, the ability to read the engineered landscape has become a critical risk management tool for property owners.